Hello everyone, this is Ali Reza. In this video I will do some refactoring on node editor window and node creation pop-up. Well, the very first day that I developed my node editor window, I thought that I can put messages into the status view. But then when I was developing my behavior tree, I was not happy, because if I had an error message, it was going up so fast that I couldn't even track that. So I thought, status view is redundant, so I will remove that status view everywhere. And this comment, by the way, is not something important. So going down, status view, bye-bye. And from here under views, we have the status view, bye-bye. So that's the first one. Then let me double check everything first. Where am I? I'm totally lost in my notes. Creation pop-up and my node editor window. Do I have anything else? No. That's okay. Everything should be okay here. Yeah. Okay. So in graph creation pop-up, this is where we are starting to create our graph. Okay. And we had this tree type. We nuked it. So we need to change how we handle this. So we use a type instead of our tree type. Then we have a private int of tree type, if I can type, index. Then we will have a private IEnumerable of type, not that, with capital T, and we say tree defs, and then we have a private list of string for tree type names. Okay. In constructor, instance equals that, vector that. After this, we say instance.treeDefs equals to reflection utils dot get all. I made it this. Okay. Get all types with attribute type of node attribute. Okay, and it's yelling at me because I made it private, so make it public, and it will come here and get all types somewhere public. So I will just move it up to our public stuff. After that, we say instance dot tree type names equals to new list of that. Then we say for each in instance dot tree defs var type, we say instance dot tree type names dot add type dot full name dot substring of type dot full name dot last index of character dot +1, and then I will use an extension method that I didn't write yet, and that is on Pascal case. I got this on Pascal case from, I think it was, I'm not sure. Let's see if I can find it online. Yeah, Stack Overflow. I think it's there. And that's not this guy. There we go. On Pascal case. Okay, so this is the method that I found online. He has nice asserts, and you can see that, you know, we can convert everything to everything, even with something like this or Italian words everywhere. Okay, so it's handling things very nicely, keeping that in hand. And by the way, here's the full link, and this is who it is, Johnny5. Okay, and this is the fifth answer, at least at the time I'm recording. But if you look up and down, you see this on Pascal case with the asserts. So after we do the on Pascal case, that's it. We got our full names of the types in our tree. Then in OnGUI, when we are using the tree type, we say tree type index equals to, remove this part to make it easier for me, editor GUI dot popup last rect, comma, tree type index. I was, by the way, double checking my rect here, comma, tree type names, but this guy needs an array, so to an array. Okay, after that we say tree type equals to tree defs dot element at, this is using link, the tree type index. So we got our type this way. Now going down, you see the error right here, graphutils dot create graph name, and here that's okay, everything's okay here, but the thing is that our create graph signature is totally wrong in our graphutils. Okay, so let's fix this guy first before adding our extension method. So instead of tree type, we are accepting a type from system. We have the manifest. Then before doing anything else, we want to check some things. So we say if not type dot is subclass of the type of graph, then we want to do two things. First, we want to say a debug dot log, or actually instead of this, I can do something else. We can throw a new argument exception saying that type is not a graph type. Okay, and that's it. Then we have this schema. So we say var type schema equals to reflection utils dot get type, the type dot name plus capital S schema. Okay, then we have the same thing, but instead of graph and type, we check type schema is graph schema. Okay, then we say type this schema is not a graph schema type. Okay, so, and by the way, I should say type dot full name and dot full name. Okay, so, and instead of this I can use this type schema dot full name is not a graph schema type. Okay, after this we start this part, so we go for current graph, but now we can't do this in this way because we got our type, so we use this overload. If it's null, instead of returning, I will throw new invalid operation exception and saying that how can I do this? How can I do this? The invalid operation, new null reference, null argument, null reference exception. The type dot full name creation returned null for whatever reason. Then doing this, but again, instead of this overload, we now have our type schema. Okay, and if it's null, we use this and we say type schema dot full name creation return null. Now, current graph initialize. Well, we can't do this in one fold anymore because we have a type here and we need to typecast it. This is a graph, so graph that, and it will work. Then typecast it again, that, and we create the asset, we save the assets. Now we need to typecast this guy again to graph schema. Oh yeah, I found it beforehand. Take a look at my spelling. This is grag, not graph. So rename this guy to graph. Yes, thank you. So typecast it to graph schema. That. Control C. Control V, and now we need to typecast this guy to graph with capital G. Going down, we have our assets, save assets. Now, here, these to-dos, I will do two things. I will say a graph of current graph, and then I will invoke a method on it that I don't have yet. Initial setup and graph schema, current graph schema dot initial setup. I don't have them yet, but I will add them in future. Then we refresh, and that's that. The rest of the methods are the same. Okay? Well, not always. Not always. Let's go down. Load graph is the same. Well, I don't want the graphs to be here, not in graph editor resources database. Oh, let's keep it there. Then we have the same stuff. So load graph is okay now. Of course, we have two errors. We will come that. Onload graph is exactly that. Delete graph is that. Clear graph okay. I will have something here. We say if node dot permanent. We don't have it yet. It's a property. We simply continue, and we will see a node that will be permanent. Then that's that, that's that, that's that, that's that. Create node. That's another thing that we need to change. So if schema graph equals null, I will, instead of returning, throw new argument exception saying that the schema graph is null. Then we create the node. But here, before creating the node, we say string namespace, but you see that it's a keyword, so I will add an @ sign equals to reflection utils dot node space map at node name. Now this can return null. So if we say if not reflection utils dot node space map that contains key for node name, we throw another argument exception saying that node name is not mapped as a node. Okay? So after that, when we are creating this guy, instead of this hard-casted namespace, now we use the namespace that we have. If current node is equal null, we throw a new invalid operation exception. And it's not showing up anyway. There. Okay. Saying that creation of node name returned null. So I will use exceptions here too, and anywhere else that I have this returning. We don't have anything here. We don't have anything here. We are handling it here. So here we say throw new invalid operation exception $path is null. Okay, and we sent in the well, this can't be null, but we do this. Control C, Control V, and home, and go up, and will this work? I hope so. I hope so. Let's put a parenthesis here just in case it gets crazy. There we go. So that path is null. Then if that's that, okay, so graph equals null, throw invalid operation exception saying that graph at path does not exist. And the path will be this guy. Or no, actually, we should say editor window does not contain any graph. Okay? And that's that. Coming down. Now, we have the subname, current node, blah, blah, blah. After the initialize, no, after this, after this, we have the same stuff. So copy this, paste it here, and node name plus schema. Node name schema is not mapped as a node schema. Namespace, I will change it to what did I call it? No, actually, I was using it. So remove this string equals to node name plus schema, and here we use the namespace. Let's inline them without this. It should be readable now. Yeah. Okay. So if it's null, we need to throw another exception that this schema return null, and we initialize it. We set its rect, we set its graph, we say if that or that or that, then current graph schema is that, add object to asset, schema select node equals that. Now here, the selection node, check for expression, but I will say if it's equal to null, then we say schema graph dot selection node equals to new that. Okay, and that is it. Load graph is okay, and the rest is okay. So that's our graph utils, that's our creation pop-up, and basically the only things remaining is these two errors. One, the on Pascal case. So here under base, I will add a namespace for extensions, and here I will add a class for string extensions, and This need to be static. Going back to your notes, wherever they are. You see this? Copy it and paste it here. And yes, import is null or white space. Now, we don't have it here. This was for web, but we have null or empty, and that's the same stuff, okay? And that's it. So we have our extension method. We come back. We just import the namespace. The last one is these initial setup methods. So let's create method inside the graph, void that, but I will make it virtual so that I can override it in other children. And let's make it inside the graph schema and make it virtual again. And that's it. So we finished refactoring. We have one error though, and it's permanent. Permanent is a property, and where to put it? In node schema, in the node schema itself. So bool permanent will be a serialized field, and I will move it close to other publics. There we go. So permanent means the nodes that you shouldn't be deleting when you are deleting every node from the graph. For example, we will talk that behavior trees has this start node that when the tree starts ticking, it will start from there. It will, look at me, look at my errors. Boundary has an A. So it will find its start node and tells it, hey, tick yourself. The start node will then look at its child and say, hey, tick yourself. And this goes down like a waterfall. And when you reset the graph, again, the start node will be the first node that will be ticked. So when you are deleting every node from the graph, you don't want the start node to be deleted. It's a permanent node inside the graph that shouldn't be deleted. Okay? And that's the meaning of this. So it's get and set. I will make the set private. Okay? So this is half an hour basically refactoring. I will keep it that way, and I will come to the next stuff in the next video. Have fun, everyone. Bye-bye.